Hello, everyone. Thanks for having me. I don't know if it's actually projected right now or amplified, but I think they're figuring that out. My name is Spencer Krum, and I am from IBM, and here to talk about code review for operations and sort of like what a code review looks like if you're doing it to like a Puppet repository or something like that. Thanks for being here. I know Brendan Gregg is talking next door, so if you want to go to that, that's fine. I'm just pleased that it's not me in a bunch of chairs, so I'm doing great. So I'm from Portland, Oregon, which is pretty far, and I travel a lot, and I want to show that Portland is, in fact, a beautiful city. It has sunshine. Currently, it's snowing there. It's not snowing here, which is interesting. That being said, I want to point out that Portland is actually terrible. It is completely full of people. Don't try to move there and buy a house. It's full. That's enough. I want to give a big shout out to Dougal Matthews from Red Hat. He gave a great talk earlier this year called Effective Code Review, which I got to catch, which has a lot of the same topics I have. We have definitely different angles on it. But you should check his talk out because it's just as good as mine. And it informed a lot of the same stuff. So big shout out to that guy. Thanks a lot. I like to talk about where I'm from and what I do as a way of talking about why I think I have the authority to speak on this topic. I'm thrilled to come to LISA. This is my first LISA. But why do I think I'm allowed to talk about this stuff? And so the first project I'm really involved in is the OpenStack project. And there I work as part of the OpenStack infrastructure team. And what that means is there's this whole infrastructure underneath the OpenStack development process. So a code review system and some testing apparatuses and some release apparatus and all that stuff. I basically work as a system administrator, keeping that stuff online. I also work on I help with the DevOps days. I help with Vox Populi, if you've ever heard of that, and a bunch of other stuff. If you'd like to talk to me about any of these things, happy to talk to you about it after the talk. Infrastructure as code is sort of the way we got to be able to give a code review for an operations, right? Before that, it was some kind of a ticket that said, I would like to reboot this server on this day, and somebody said that looks good. When we defined our infrastructure and what is in our infrastructure through some kind of a code, a process, a program, we gained the ability to use code review on it. And the way we did that is we put our infrastructure as code. So I wanted to give a definition of infrastructure as code that I use very generically, just so that we're all talking about the same thing, although obviously this is a conference that doesn't need me to define infrastructure as code. So basically, I define it as this. So like it's infrastructure changes performed by a machine. So nobody's doing anything manually, right? Some Bastion host or some Jenkins master or something that is not a person is consistently updating the changes to the infrastructure. And that is fed deterministically from some program that is on disk somewhere, some program that is in Etsy or in var or whatever. But it's some file, some text file that's driven there. There's no artifacts. There's no humans typing in passwords, that kind of stuff. And it's done on a regular cadence. So whether you're doing it with something fancy or you're just doing like a cron job like me, some cron job is deterministically taking that code and changing the infrastructure, resetting. If you're a Puppet person, you might be saying ensure state right about now. And then we take that code and we track it in version control so that Git is the thing that is keeping track of which version of the infrastructure is deployed right now. And then finally, and this is really what I want to talk about today, we're reviewing changes to that code base with our peers. Right? So if you want to make a change to the infrastructure in this environment, which is the environment I've worked at in multiple companies in the Fortune 100, as well as the OpenStack infrastructure project, you have to make some kind of a peer-reviewed change to a Git repository with the knowledge that this cron job will pull down that Git repository and then run some program that will, oh my God, I do not know what that button did. Okay. Cool, all right. Get excited. So with the knowledge that the code that you changed with that Git repository change is going to end up changing the server somehow through some cron job, right? It's pretty straightforward. And so for me, the definition of code review is really straight. It's landing code only after it has been inspected for defects and accuracy by multiple team members. Or maybe just one team member, but not just you. And this is different than a lot of the code review research I did. So I did a lot of research preparing for this talk, or a little bit of research preparing for this talk. And for a lot of people, code review means they lock all of the developers in a room for like 3 days. It makes them read the code. And they just keep notes on everything that has happened. And it sounds just brutal, just totally terrible. So how does this idea of code review, how does that affect pair programming? So I don't actually do a whole lot of pair programming. I work remote in my room, often a hotel room. And so I don't necessarily sit right next to some people. But the idea here, where you propose a change and someone else looks at it and approves it or says, no, you need changes, is kind of, I think, perpendicular to what we get out of pair programming. You get that every second that you're pair programming. But when you have two people that are pairing and they write the change together and they submit the change, and then that second person, eventually one person submits it and somebody else approves it, I think that's not as good as actually having those two people send the change up and letting another team member look at it. Because a lot of the advantage we get out of this is that other team member paging in the entire idea of what you want to change, and they don't have any of the baggage that you have from the last 3 hours of debugging the problem that motivated that change, right? So they're a little bit further away. They don't have the biases that necessarily you do. So I have some vocabulary. Oh. Uh-oh. Oh. Oh. Okay, so OpenStack. Was it on OpenStack the entire time I was talking about code review? Okay, these are getting a little out of sync. We'll work with it, we're fine. Operations. So OpenStack, I just want to give you a little heads up of what OpenStack is. I think most people have heard of OpenStack, but when I'm talking about the velocity, the code velocity of OpenStack, I run a developer infrastructure for OpenStack, and I'm sure a lot of people run developer infrastructure, but ours is something like 600 Git repositories, and then on those repositories, about every 6 months, we land something like 20,000 commits, and then to those 20,000 commits in a 6-month period, we launch something like 100,000 reviews. These numbers are all pretty conservative and from the past, but that gives you an idea of how much code OpenStack is chugging through, and then how fanatical we are about reviewing that code. So when I work on an operations team inside OpenStack, anytime somebody puts a change up, whether it's modifying one line of a YAML file or booting 300 servers, that change goes through a policy that we call the 2+2s rule. So basically, of the core reviewers, which largely means the root team, 2 people that aren't you have to go +2 the project, +2 the change in order for it to land. That's a social rule, not a rule we enforce, but it's a social rule. We'll talk more about that in a minute. So already you used some vocab, but I want to put the vocab out in place so that everybody knows what I mean when I'm talking about some of these things. So for me, a review, a change, and a pull request are all basically the same thing. It's the web view or the minimum amount of change to a Git repository that you've proposed, right? A robot is just some kind of an automated process. So for me, a robot runs a test, or a robot cuts a release, or a robot runs Puppet on a server, something like that. A review is also a verb. So for me, a review, like I'm going to review this, or I'm going to give you a review, the robot posts a review to the change. That's just basically the robot saying, I have this feedback, and I'd like to give it a -1 or a +1 or a +2 or something like that. Land, for me, is the object of merge. So you land a change means that piece, that diff or whatever, is now part of Git master or whatever, subvert trunk, I guess. A core, very specific to OpenStack and open source really in general, but that's a coder with commit bit. A non-core is a coder without commit bit. That obviously has some parallels in the business world, but it comes from an open source place. And then a patch set is probably the hardest thing to understand if you're not used to Garrett, which I am. So Garrett is what OpenStack uses. GitHub is, I think, or something that looks like GitHub is what most of the world has used. And a patch set is a revision of the proposed patch. So on OpenStack, what we do is we'd make a change, and somebody would say, hey, -1, I need you to make it slightly different. And then you'd go and you'd make a second patch set on that same change. And it might not actually land until patch set 4 or 5 or 9 or something like that. Some patches, big patches in OpenStack get up to like 200 revisions. GitHub has this unfortunate feature where in order to update the pull request, what you do is you do a force push over the branch, and that deletes any knowledge of what was on the patch set before it got feedback and was updated, which is not the worst thing in the world, to be clear, but is annoying when you're used to having that data. Kind of a difference between a lossy and a lossful system. A lossless system. Okay, so in OpenStack, the OpenStack infrastructure project, which is again about supporting open source developers, what do we use code review for? We have run a bunch of daemons. So if we want to modify those daemons source code, we modify the daemons through, we make a change, we push it up to code review, people review it, we land it, some automated robot restarts the service. If we want to change the configuration of those daemons, right? It's just Puppet or Ansible sometimes these days. You make a change, you push it up, people review it, it goes down. If you want to change package file services, we run a bunch of images. Anytime you want to change our docs, it all goes through Git, and that means it goes through code review. And as soon as it lands in those Git repositories, some kind of robot deploys it out. We also have all these test definitions in OpenStack. So I think a lot of people are familiar with travis.yaml. We kind of took 600 Git repositories worth of travis.yaml and throw them into one file, which is like 7,000 lines of YAML. And it takes a whole city to maintain that. But we do it through code review. And this is like one of the big advantages we get out of code review, right? Is like if some project inside the OpenStack umbrella wants to modify their tests, there's kind of a core group of people that maintain that file that are like, we like your change, we like what you're doing, and we'd like you to make the change slightly different so it's in line with all these other projects. If you'd like to create a Git repository on our 600 and always growing list of Git repositories, you modify a YAML file and submit or code review. If you'd like to set up ACLs for that Git repository that you just created, you modify a YAML file and submit a code review. If you'd like to register an IRC channel for that project that you just created inside OpenStack, you modify a YAML file and submit a code review. If you'd like to set up so the IRC bot yells in that channel that you just created after you created the Git repository and the ACLs, you modify a YAML file and you submit a code review. And so there's this whole component of community management and infrastructure for developers that we manage through YAML, through code review. If you'd like to run for an OpenStack elected position, you modify a YAML file and submit a code review. If you'd like to release some software, you modify a file that's, I don't think, in YAML, and you submit a code review, and people are like, -1, this should be a full release or whatever. If you'd like to add a new dependency to OpenStack's source code, like a new Python dependency, that goes through code review, and that's significant because it's not just like, oh yeah, we want to use whatever software we found on PyPI, right? Like we want to make sure that the licenses that are compatible, not just the software we write, but the software that we depend on transitively. We want to make sure that that has licenses that are compatible with our mission so that people who are making OpenStack installers and products can vendor that in and ship it to their customers. If you want to modify our Grafana dashboard, you want a new dashboard on our webpage, you can go to a YAML file and submit a code review. If you would like a meeting in one of our IRC meeting channels, you can get that out. Point is, we go a little nuts on the code review. So why do people do this? Well, in OpenStack, it's so that you can have a little bit of pain in your daily life. But there's three big reasons. There's three big reasons most people do code review in anything, whether it's operations focused or not. And the big ones are like less defects. Right? The second one is a wider understanding of code. Like more of your team will know more about the code that you're responsible for, and of course for us, infrastructure that they're responsible for, if they didn't do this process. And the third thing is it slows your Brents. So I won't be the first person at this talk to ask this question, but how many people have read the Phoenix project? Okay, so maybe 75%. For those of you who haven't, there's this character in the Phoenix project, which is a novel about IT. It's a little weird. But there's this character that we've all worked with called Brent, and the company can't do anything with computers unless Brent is involved in the project. They just don't know how to get the SAN back online after a failure. They don't know how to deploy the application's new version without Brent, right? And so in any organization, there will be some person that's just, this work is beneath them, or they're just super smart or whatever, and they want to go really, really fast. But if that person can only go as fast as the process of them submitting code changes to the whatever infrastructure repository you have, and then other team members reading it and approving it, then that person necessarily slows down, and your team members have a chance of figuring out what that person did to resolve the issue or deploy the application or whatever. Now, it's not perfect. That person can still be like, well, I don't know, I trust you, Brent, approved. And we'll talk about that a little bit later. But you have a chance. There's also some academic research into this. And one of the interesting things that came out of the research that really others did and I copied is that the bigger bugs in your software, this is about software, not about operations, but the bigger bugs did not actually appear. Defect-related comments comprise a small proportion and mainly cover small, logical, low-level issues. Right? The bigger issue of, no, that code doesn't work because we didn't think about something, that rarely gets caught in code review. But what does value in copyright are knowledge transfer, increased team awareness, and creation of alternate solutions to problems. Like, do we really need to be doing this here? Does this code look like the other code in this other repository? That kind of stuff. So if you adopt a culture, that I'm basically the call to action here is saying, I would like you to adopt a culture of not just pushing stuff into your Ansible repo, your Terraform repo, and your Puppet repo, but instead always proposing a pull request internally so that your other team members have a chance to knack or ack that change. And there's going to be some changes you're going to see in your organization if you do this. And the first one is that merge speed becomes an issue. It just takes longer to get work done if it's not all you, right? You have to wait for someone to get a review, and you're constantly going to be annoyed in the middle of your workday for people asking you to review their changes, right? So the whole thing kind of falls over. Instead of taking 3 hours to write the change and 30 seconds to give it to Git, and then Puppet takes whatever, an hour to do whatever it needed to do. It's now 3 hours, and then who knows how long until you get feedback, and then an hour to do whatever you need to do. But the idea here is that the advantages you get are better than these defects. So auditability is something that comes out that you didn't have before, right? If you're controlling everything with Git, you have a basic Git log command in order to tell what's happening. But probably if you used a Git, like a pull request system, you have this whole directory, this whole web interface of pull requests with searching of who created the change, what did people have to say about it, and then who finally approved that and landed it on production. Something to consider, though, is that access control moved from whatever Unixy system you were using to your code repository. So whereas you might have had some, only people with SSH access to this server had the ability to push into the Git repository stored on that server, which was a handful of people. Now you're trusting your GitHub Enterprise solution to not root all your servers. So that sucks, because that thing was written in Rails, like probably very quickly. But there's a better side of that, which is that they probably took the time to really implement some like role-based access control in that code review system, which you did not do. And I don't care whether you say you read pseudo logs or don't. You don't read them. Don't even try that crap with me. So you're going to have a better ability to audit what happened and fine-grain people's permissions down to the point where you can really control what they are and are not allowed to do. Now, if you're 3 people who have root on all the servers at your small company, that doesn't matter that much. But I work at slightly larger companies like IBM, where it matters. The other thing is that your testing won't really have the coverage. Like most of the time when you're running a software development project or you're using some software to develop, you're developing software in some way, everyone wants tests. They want all this crazy testing. They want to write tests. They want to run the tests. They want full acceptance tests. And I get that. That's great. You should definitely do that. But if somebody tells me in a meeting that we're going to have full acceptance test coverage on every line of Puppet in our repository, I just laugh at them like, no, we won't. That stuff's really, really hard to make and never works very well. Not saying you shouldn't try, but you can die on that hill too. Remember the Alamo. OK, so small changes can have a huge impact, and that can be very stressful, right? One pull request goes up that's changing one line of one of those YAML files in OpenStack. And sometimes that change lingers because it's scary. It's not just adding an IRC meeting to some repository. It's adding, it's increasing the gain on our control system that boots virtual machines, right? This has huge impact. And so sometimes people will be afraid to push that button. And so one of the things we'll do to solve that problem is we'll have this idea where many people who theoretically have the ability to approve the change will all go give a soft +1, like a +2, but not approve it on the change, so that everyone in the root group is like, all right, we're kind of all making eye contact through this web interface, and we're going to make sure that we agree that this big thing is going to happen. And that's something we do that. So those are some of the organizational changes you're probably going to see. And I want to talk a little bit about the human behavior changes that happen if your team really commits to this. Because I've worked on 3 teams that worked on code review-based infrastructure changes, and I've seen some patterns emerge in how humans behave in this environment. So the first one I call the YOLO system. And so remember, OpenStack has this idea that 2 people that are on your team will like +1 or +2, we call it a +2 in OpenStack, but they'll thumbs up the change, and then that second person actually presses the thumbs up and the merge this now button, the approve button. They press the merge button, right? And so what I call is YOLO first person and YOLO second person. So if you're that first person, and it's maybe the early morning or the late evening or whatever, and you're like, well, this very smart person wrote the change, and this other person's going to have to review it anyway, so I don't really have to read this very well. This definitely looks like code. It says it's installing something, and I see that package name in there. Yeah, +2, stamped, rubber stamped, right? And then that creates this problem where, especially because it's always like one person on the team that is known for doing that. So that means that second person coming along has to wonder whether that first person really read the change. And that puts a lot more pressure on that person to find more bugs or maybe not actually interact with the change because it's scary, because they are ultimately on the hook for whatever they approve to go into production. Secondly, you get that second person YOLO effect, right? Where Well, a very smart person wrote this change, and a very smart person that I respect gave the first +2. So I'm just a bookkeeper now. +2 approved. Let's go to production. That sounds fine. It's all good, right? There's a lot of reasons to maybe excuse yourself from reading the code intensely, and you have to kind of fight that resistance, because what'll happen is people will be afraid of following up on changes that you've submitted or following up on changes that you've reviewed, because they know that the review quality maybe wasn't there. Imagine for a second if the first and the second person met on the same change. What would happen? All right, so chickens and pigs, comes out of Agile, I think. I was told it is a story, but it doesn't really matter that much. Do people know what I mean when I say chickens and pigs? Okay, raise your hand if you do. Not very many. All right, so there's this parable, and obviously it relates to project management because, I don't know, I work at IBM. Okay, so the chicken and the pig are walking down the street, and they say, hey, we should open up a breakfast place, and we'll call it Ham and Eggs. And the pig is like, ah, ha, ha, ha. So you're just involved, whereas I'm committed. It's called Ham and Eggs. The idea there is that imagine every meeting you've been at. There's been people that are really committed, like they are ultimately, this is their primary job, whatever we're building. And there's people that are just there because they got invited to the meeting and they know some things about databases, right? So there was this idea, I think and I think they actually took it out of Agile too, where you would have people that weren't allowed to talk in meetings unless they were asked to talk, because it allowed it to focus on what really needs to be done by like key stakeholders and architects and builders and stuff, blah, blah, blah. That's all good. What this means in a code review context is that on your way to building something that allows code review to happen, you created the ability for someone who does not have root to propose a change to your Puppet repo or your Ansible repo or your Terraform repo or whatever. And so that means somebody who's in QA or is on the database super specialist team or somebody who knows a lot more about the JVM than you, even though they don't have root on your systems, they can pull down your code, modify those XMX, XMS args that all Java programs get, and push up a change. And then you, as an administrator, can approve it and let them modify your code. Let them modify your infrastructure because they do know better than you, and you want to be able to, you enfranchise those chickens that have been disenfranchised by the classic, we're ops and we don't let anybody see what we're doing. Secondly, you can write your own change to something that's more complicated than maybe you should be touching alone. And you can send the link to that pull request or that code review or whatever it is off to that team and say, hey, if you guys get a few seconds, or you people get a few seconds, if you could maybe have one of your Java experts look at this and decide if I'm crazy or if this is a good change, and they can come through, and probably they have the same user access rights on the pull request system as you do to give a little +1 or a +2 or leave a little note like, hey, this looks great. Thanks for making it. Appreciate it. And you can really make the whole system, the whole organization talking about the same thing. You can get everybody, you can get feedback from people you otherwise would not have had feedback from. And that's incredibly valuable. There's this other thing that happens where managers probably also have a login to your code review system. And so whereas managers before would be like, yeah, make the thing. I'm going to go approve some expense reports or whatever managers do. Now they're like, oh, I remember when I was technical like 7 years ago, and they'll come along and they'll leave like minus information. Like, no, don't merge this because I want you to use this other piece of bash that I know. And everyone's like, what are you doing? This is not, no, what do you want? And then of course they just leave. So you respond to them in the code review, and it'll be a month before they come back. So what we've done in the past, we had a manager that would do this from like every 2 weeks, would roll up on all the changes and provide all this weird feedback. And so what we told this person is that the code, and this is a good lesson to learn, is that the code review system only works if it's nurtured like a garden, right? If the only time you ever interact with your code review system is when you've written your change and you go to get the link and paste it into Slack, like yell at everyone to review it immediately, it's not going to work very well. You have to have a system of and a culture of consistent everyday review. So you get there, and what I do is I get to work and I read my email, and then I go through the open pull requests and I look at which of my teammates' patches need feedback from me, and I try to give as much feedback as I possibly can, and I try not to ignore things that look hard, because the only way that team member can get their project done is if I put feedback into it. And so what we told the manager is be consistent or don't do it. And usually that kind of shuts the manager up, but there's only so much you can do there, of course. So there's also this thing called patch size. So whereas before, if you're working on your own project in your own branch, you can make it as big as you want. If you are instead preparing a patch to a project or to a repository that you need other people to interact with, patch size matters quite a bit. So one idea is this code review, 10 lines of code. People are going to find lots of issues with it. 500 lines of code, they're going to be like a rubber stamp. Just Yep, that looks good, right? And it's because they don't want to interact with 500 lines of code. Nobody does, right? Especially if you're yelling at them to do it, or for some reason they just feel pressure to go quickly. The other side of that, though, what's not captured in this tweet, is the idea that if you submit a 500 line of code patch, it might just sit there with no feedback on it. And that's because people know it's 500 lines. They probably opened it and looked at it and immediately got scared and went to do something else, right? Because they don't want to be on the hook for approving something, but they also don't really have time or encouragement, or they don't want to interact with 500 lines of your code that you wrote in like whatever Ruby or Scala language you picked up off the shelf. Work in progress changes, right? So ops work in general is pretty difficult to get visibility into. Like, how is this project going? You're like, I don't know, I'm working on it, right? So what you can do if you have a culture of code review on top of a culture of infrastructure as code is you can submit the change before it's ready and use some socialized word like work in progress, do not merge. In OpenStack, we put a -1 workflow review on it. And what that means is that no one will approve it. They know not to approve it. In fact, they know not to waste their time looking at it because you've identified that it is in a state that is not ready for review. You don't want to waste your coworkers' time. But what you can do with that is you can push it up and know that it's no longer just on your laptop. You can push it up and go on vacation and say, like, this is how far I got, I'm going on vacation. If anybody really wants to pick it up, you can. You can push it up and use that as a link in some kind of a status report. Like, this is how far I've gotten on the changes to like bring up a new VPC in Amazon and some Terraform code or whatever, you know. If there's another team that you're working with, you know, some database team wants you to make them some servers or whatever, you know, it's very hypothetical, but you could send them the link to the work in progress and be like, hey, does this look like what you think we should be working on here, and collaborate through that. So it's really useful to be able to send that work in progress change up to the code review system. Silence means no. It's batched to this, you know, it's true everywhere else, so why not in code review, right? So go back to the idea of 10 lines of code or a 500 line code patch. If you push up a patch that's too big, people won't say yes, they won't say no, but they won't say anything, and that means no. You also run into this issue where people will, you know, classically in any ops, there's like maybe quick and dirty and like correct and elegant, right? And so very often the quick and dirty proposal will be sent up, and the contingent that would prefer it to be done correct and elegant will just not vote on it because the change that you made is not wrong, it's just not the change I want. And there's no particular line of code I can find that is wrong in the change you made, it's just not the way I want to approach this solution. And I don't necessarily want to be the party pooper on the team, so I'm not going to say anything and I'm just going to let that thing atrophy. And of course, if it's a code review patch, you know, it's a patch targeted at a Git repository, it does atrophy. It doesn't just sit there happily because the master branch will move on, and then this proposed change runs into rebase problems, it runs into doesn't merge anymore problems, it runs into it hasn't been tested in a long time, whoever wrote it doesn't remember what it does, that kind of stuff. You end up with a lot of cruft in your system. So just walk that out, you know, and there's a couple things you can say if you are that person that doesn't want that change to land. Like, I encourage you to stand up and say, the direction here I don't like, or I don't have time to do it right now, but we need to do this better, or there's this other section of code that I wrote that I think is the right approach to that problem and could be adapted for this problem. You know, there's a million ways to say no without being a jerk about it, and I encourage you to do that because just letting that change lie there really hurts your coworkers' feelings. It doesn't sound like, you might not sound like it, but it does. Especially newer people are going to write changes that just are weird. You're like, I don't know why you're doing that. And so you really want to reach out to that person and say, I don't like it for these reasons, as opposed to just being like, I don't have to approve that, so I don't have to interact with it. There's this other idea of forcing the issue, which is related to the silence means no, right? Especially in an ops team. You might end up in a situation where there is a patch that is liked by some percentage of the team and not by some other percentage of the team. And there's a hostage situation that sort of develops there where the 2 or 3 people that really just want to quick and dirty it done or use Ansible Vault or whatever piece of software that the rest of the team is pretty, I don't know what that on it, they can actually just propose a patch and then someone else can plus to it and then someone else can approve it while the other team members are kind of not paying that much attention. And so you can feel like you're being held hostage. Like, I can't do any work right now. So I need to be constantly watching the review queue for these bizarre changes that are coming out of nowhere that I don't like. And so what you got to do is you got to work with him. You got to work with whoever you're talking to. You have to work with your coworkers. You have to say, why are we doing this? What is the actual pressure? And maybe you need to say, all right, well, the world is not built of bunnies and rainbows. So we don't have infinite time to do all things correctly. So if this is the best way forward, maybe I should let you do it and get on the team. That kind of stuff. These are some of the human things I've seen. So what are the biggest advantages to me about moving to a system where your infrastructure is changed only through code review? So the big ones are just fewer mistakes. Less times people type in a package name and it turns out it was not PyYAML, it was PyYAML2, and your buddy looked that up and found it out. That audit trail is really useful. Why did this happen? Why did we do this? You know, I don't know how many times I've gone into a Puppet repository, a previous job, and I was, you know, Googling or git log and git blame, and I eventually find the change that added this package or whatever, you know. And it says, and I look at the commit message, and the commit message is do the needful, and I'm like, great, this is great, that's what I want. If you know that you are writing a commit message and a diff specifically for other humans to read, just the way an open source project works, you are going to write a more complete commit message. It's just the way it's going to work. And that means that 6 months down the road, whether it's you or a different coworker, if you're asking, why did the code change, that commit message is going to have a lot more context than fight the fire of today. It's just the way it works. I think empowering the chickens is absolutely one of the best things that comes out of this. And OpenStack specifically, we were on a couple big Java things that, like in the JVM. And I don't know that much about tuning the JVM, but we do have one person on the team that does. And that person is a chicken. That person has a lot of other work to do. But when we are in the mode of like, hey, the Java is not Javaing correctly, he can show up on these reviews or propose his own reviews or his own changes to Puppet to modify our JVM parameters and even some of the Garrett internals, which is really nice. There is a caveat to it, which is that person will, there's a reason the Agile Manifesto or the Agile book or whatever kind of disenfranchise that person, which is that they're so laser focused, they don't necessarily know what's going on in the larger context. And so what we did is we actually just approved this person's patches without thinking too hard and introduced a security problem, which we later found and fixed. But it happened because we weren't doing a good enough job of saying, all right, thanks for making this change. Do I understand this change? What are the larger impacts of this change? Just something to think about. And really, that peanut butter smear over your toast of knowledge is what I really like about this. It's no person can modify the tree in a vacuum. People will know what changes, other team members will know what changes are being done with the Elasticsearch. Like, especially Elasticsearch is a great example of something that usually one team member goes off in a corner and builds. But in this environment, if you want to make Terraform, Ansible, and Puppet changes, you have to take that through some kind of code review. And that means that other team members have to have at least some understanding of what you're building and what was changed, which servers are involved, what packages are being pushed out, and what control mechanisms you're using. So those are my thoughts. These are a bunch of references for the people that are looking at this talk on SlideShare. And thank you for your time. Do you have any questions? There's an audience mic. Can I go back? Oh, these are all online. My talks, so here, take a picture of this one. I should put it on there. Take a picture of that, and then you can get all the references as text. Yes?
Okay, you talked about CRUF. If you get a lot of CRUF in your system, how do you get rid of that? How do you manage that lying out there?
Are you talking about proposed changes that haven't landed?
That get abandoned, yeah.
Yeah. So like the classic example is, you have a bunch of team members and they write all these changes like, I'd like to install such and such package. I'd like to, modify this Apache vhost file, whatever people want to do, right? Why is that hanging out? And the answer is, why does it sit there?
No, the question is, what do you do about it if it is there?
Yeah. So it's there. What do? Well, so I think the only reason it's sitting there in a pending state, like what's the life cycle of a patch, right? It goes from proposed to either up to merged or down to closed, right? And there's no good reason for any patch not to find its way into one of those two buckets in a nice, short amount of time, like a week or something, whatever your review cadence is. And the reason that it didn't land is because somebody used silence means no, right? If it was an obvious change that had no negative effects, people would be like, all right, sure, I don't care. If you want to install Emacs on all the servers, I don't care. But if it's something that's like more subtle and gets into people's opinions that are probably not related to business need because it's old, then someone is blocking it or unenthusiastically not approving it, or I guess you can do this, it's okay. Somebody left some passive aggressive comment on it, right? And so what you need to do is you just need to be more direct. One of the things I really like about the system Garrett that we use that's different from GitHub, and GitHub is starting to change this a little bit, is Garrett actually requires you to give a numeric vote in addition to whatever text you wrote. So you have to give +2 or minus. You have to give a positive or a minus vote. And so that forces people to kind of come down on the side of like, I want this or I don't want this. None of this like leave a weird question on the review and then leave, right? Like that's why they're probably hanging out, is because people haven't been clear about what they want and what they want to solve. Okay, thanks everybody. I'll be around the conference and enjoy your break.